Proper and periodic sprayer calibration is crucial to accurately apply fertilizer and pesticides to your crops. Calibrating a boom sprayer is simple and easy if you follow the method outlined in this program, and it should only take about 15 to 20 minutes of your time. This calibration method is infinitely scalable to any boom sprayer regardless of the size or length. Frequent calibration helps prevent over or under applying fertilizers and pesticides, saving you money, protecting the environment, and ensuring legal compliance. Under application can lead to weak turf and poor pest control, while over application risks plant injury, environmental harm, and illegal usage. Ultimately, poor calibration wastes time and resources. Before calibrating a sprayer, it's important to designate a helper. This method works best with two people, one to operate the sprayer and one to record the spray time. Check that all sprayer parts are functioning properly and that there are no leaks. If necessary, adding colored dye to the tank can assist in identifying any leaks. Nozzle selection can vary depending on the site or what you're targeting. Here are a few general guidelines to help choose the right one. Flat fan nozzles are best for backpack or handheld pump sprayers, especially when working in turfgrass areas. Full cone nozzles are ideal for high-volume hose end sprayers that need to cover large areas. Adjustable cone nozzles or nozzle hoods are typically used for very large applications like ornamental beds or garden spaces. To perform an accurate sprayer calibration, you'll need the following tools: a properly functioning sprayer, a measuring container, ideally marked in fluid ounces. Metric units work too, but you'll need to do a conversion afterward. A timing device, a stopwatch or smartphone works great. A measuring tape, and wire flags or cones to mark your calibration course. This calibration method only works when the square footage of our test area, in effect the calibration course, is 340 square feet, which is exactly 1/128th of an acre. There are also 128 ounces in a gallon. Therefore, using a 340 square foot test area will give a direct translation to gallons per acre, or GPA, after the timed outflow of water is collected and recorded. For this demonstration, the calibration course is determined by first measuring the distance between nozzles on the boom. In this case, that nozzle spacing distance is 32 inches, which translates to a course of 127 feet in length based on the manufacturer's recommendations. With the sprayer tank half filled with water and the course marked out, drive through the measured distance in the field at your normal spraying speed and normal pressure, and record the travel time in seconds. Repeat this procedure and average the two measurements. For this demonstration, the two measured runs averaged about 20.5 seconds. With the sprayer parked, run the sprayer at the same pressure level and catch the output from each nozzle in a measuring container for that measured time. In our example, each of the three nozzles produced about 15 ounces in each timed output. Calculate the average nozzle output by adding the individual outputs and then dividing by the number of nozzles tested. If an individual sample collected measures more than 10% higher or lower than the average nozzle output rate, check for clogs and clean the tip, or it may also be necessary to replace the nozzle. Repeat the collection and cleaning steps until the variation in discharge rate for all nozzles is within 10% of the average. The volume collected will be the sprayer application rate in gallons per acre. For example, if you collected 15 ounces of fluid in the test, your final rate will translate to 15 gallons per acre. Compare the actual application rate with the recommended or intended rate. If the actual rate is more than 5% higher or lower than the recommended or intended rate, you'll need to make adjustments. You can start the adjustments by changing the pressure. Lowering the spray pressure will reduce the amount of spray delivered. Higher pressure will translate to more spray being delivered. Make sure not to change from the pressure range recommended by the manufacturer for the nozzles you're using. You also can manipulate the application rate by changing the actual travel speed. Slower speeds mean more spray will be delivered. Faster speeds and less spray is applied. If these simpler changes don't bring the application rate to the desired rate, then it may be necessary to select a new set of nozzles with smaller or larger orifices. But remember, a change in nozzles will require a brand new calibration. As mentioned earlier, if you're using a metric measuring container, you will need to convert milliliters to ounces. For reference, we know that 1 milliliter equals 0.033814 fluid ounces. For your conversion, take the milliliters collected, then divide by 29.574 to determine the amount in fluid ounces. With many differences between application equipment, such as tractor speed and pump applied pressure, calibration of your equipment for each piece of equipment is important in order to assure a high level of application accuracy. Environmental and monetary waste can be avoided with regular calibration of your application equipment.